And hello, friends. Welcome back. Thank you, Nick. I did love that segment. We did a bunch of vending generative AI art, and isn't that cool? And Nick, you do indeed have a face for a camera. Otherwise, we wouldn't let you on. Well, friends, welcome back. Welcome back to AWS OnAir. Now we have a very, very special session. I'm joined here today by Rob, by Alak, and by Suresh, and we're going to be talking about something that's incredibly important, something that's hard to achieve, but something they've built, a way to do a two-way translation of American Sign Language. Now, without, uncovering too much, I'm gonna let my guests introduce themselves first. I want to, first of all, give thanks to our ASL interpreters here, so thank you so much. And I will let our guests introduce themselves. So let's start with the man of the hour, Rob. Rob, tell us who you are and what do you do?
Hey everyone, I'm Rob Koch. I'm based in Seattle, Washington, and I work for Slalom as a principal for the data engineering group, and I'm happy to be here. Thanks for having us, Darko.
Thank you so much, Rob. Okay, Alak, tell us a bit about yourself. Who are you, what you do, and, well, why are you here?
Well, thank you so much for having us here, Darko. My name is Alaki Shwaradas. I'm a principal solutions architect here at AWS.
Thank you so much. And finally, the man who has the laptop with the demo. We have Suresh here. Suresh, who are you? What do you do? And all those fun things.
Yeah, thanks for having us. My name is Suresh Pupandi. I'm a principal solutions architect with AWS based in Chicago. I help life science customers.
Amazing, amazing. Okay, so let's kick it off. Let's kick it off with what is the problem we're solving here? It kind of seems pretty obvious, but I'd like you to tell me what is this thing you've built and why?
Yeah. I mean, one of the common things that I get asked is like, why can't subtitles or captions be enough? Why do you need sign language interpretation?
Right.
I do think that English is a foreign language completely to American Sign Language users, and there is a global interpreter shortage.
Oh,
right?
Absolutely.
So we came up with a solution we called Gen ASL, which is a multimodal generative AI powered application which can do this bi-directional translation. It can take audio, translate that into an ASL avatar video using these multimodal models, and do the reverse translation, taking a ASL video, convert that back into English audio.
Amazing. Okay, that is pretty good. And Rob, what part of this were you? Well, what was your part in all of this? Because I see this is a very important aspect in your life and all those things. What did you do? How did you work with Suresh and Alak on this?
Sure. So first, coming up with the Gen ASL concept, I got involved with some of those folks as a AWS data hero myself. I recognized that part in the industry. So these lovely folks helped me, invited me to help them out in a way to make some suggestions of how to design and also to implement things the right way so that we're not to a point where, a hearing person is taking over our language in a way. It's our language as a deaf person in the deaf community. So wanting to make sure that from the deaf community perspective, that was included, and it makes it so that it works for all of us as well. And so they invited me to help out with the user experience portion on the app. And so that was part of my contribution here, and they've been great partners with all of this, and I've really enjoyed working with the two of them. And we've done 2 talks so far. We'll probably have a few more coming up, right?
Exactly.
Amazing. Okay, thank you so much, Rob. And Alak, thank you so much. I think we're gonna kick it off to Suresh to actually see this thing in action, and more importantly, see how this thing is being built. So, Suresh, take us off. We're gonna look at Suresh's screen right now, and let's actually have a look at this thing in action.
Yeah, let's start with the demo.
Okay.
Rob is going to demonstrate it. I'm just going to play that one now.
Hello, everyone. Welcome to Reinvent 2023.
Correct.
This year, I'm especially excited to stand on this stage and share our vision with all of you. That's because this year, we are standing at the edge of another technological era. An era in which a powerful relationship between humans and technology is unfolding right before us.
So we have several demos within this. This was the live stream from last year. So just showing that you can upload a video. We have, in this case, used Swami's talk from reInvent last year, and you can see those things coming up here. Now the video is going through the LLM. It's being translated into ASL Gloss. You'll probably notice here you're seeing some of these things that say like IX1P and things like that.
Yeah.
That means first person, and some signs will have different, different. It's a linguistic representation of American Sign Language, so that's why it looks like that. It's not like English text. So it's picking up the gloss, and then we'll go to the ASL video where those are being stored, and it's pulling out. You see the lady that's on that box on the top. So it's pulling all of those videos that we have, like we have a dictionary that we're using. So it's putting those all side by side as it's taking from the ASL gloss. And then below that, we have the stick figure, which is the machine learning library. That is drawing out that stick figure that you see. And then from that, it comes up with the ASL avatar, which is the one you see on the far right.
This is fascinating. So my understanding is when it comes to ASL, it's not just the hand movement, but it is also you need the elements of facial movement. That's why our 2D avatar has those facial elements.
Absolutely.
Yeah. We are using a 2D post-estimation algorithm. So that takes a human image and then identify 133 key points, like all the joints, but the lips, eyebrows, and then capture that, because that is important for the ASL to express the signs.
Okay. And how much data do we need to kind of generate these things? Because I assume you mentioned a library with sign language videos. Is that a lot of video data that we have to throw on to this application? Is this something that we're I assume we're using generative AI. Are we fine-tuning a model here, or are we doing some other approach to this?
Yeah, this one we are using Boston University's ASL lexicon video dataset.
Okay.
Boston University created this dataset to help in the ASL research space. So that video dataset has like a 4 signers signing 2,500 unique signs.
Okay.
So it has like 10,000 signs. So if we don't have the sign in the sign database, so it fall back to finger spelling. So we have the alphabets for each 24 all the alphabets. We have the signs for each alphabet, so it fall back to that one.
Okay, that is an interesting thing. And is that fallback being have you developed that within your application?
Within the code, I'll show you the code.
Okay.
Yes.
Can we go in and look at some of that, or is there more demos to this one? So let's switch to Suresh's screen right now and have a look at this in action.
Yeah, we'll have one more demo.
Okay, let's do it.
So this is going to demonstrate bidirectional.
Okay.
Rob, take it over.
Sure. So this one here, we were talking about the bidirectionality. So checking into a hotel is the example we used. So I recorded myself signing a few of these phrases, and we upload the videos to here. So I said, "Good evening," and then they'll assume, that the hotel front desk person will respond. So you can see that here. "Good evening, welcome to the hotel name." And then it will find in that Boston University dictionary, lexicon dictionary, it will then pull out the possible words. Some words from the dictionary that aren't there, again, those are being fingerspelled. And then they go back and forth with the interaction of the conversation. So they're talking about the reservation. So it's a lot of work going on in the background, processing all of this, going through the LLM, translating it to the ASL gloss, then generating the avatars and making that all put in the right place. So you can see here that the gloss is changing a little bit as it evolves. It's filling in you see in the gloss that there's no filler words. So even in LLMs, they have filler words in there, things like that, but it's not included here in the ASL gloss.
I love this. And
so you can see this interaction going on.
And Rob, my question for you, how real time is this, and how it is for you as a person who requires ASL, how convenient this is compared to something else?
So this is not production ready,
okay.
Of course. We're still in the infancy of the whole industry, LLMs, AI, all of it. And so it's nice because some use cases you can't hire sign language interpreters to be at every single interaction that I do, right? So it's really nice to have I guess, a crutch, if you want to call it that, a tool to, a lot of different nuances that come to translating, like the avatar. It's the same speed all the way through, right? So when a sign language interpreter is doing finger spelling and things like that, they tend to slow down so I can see the letters that they're actually spelling. And then going back to signing, it gets faster and then catches back up. So there's a little bit of a lag to when the hearing person is speaking. And this is kind of this dance that we do where we're like lagging behind and then we catch up, lagging behind and catch up. And so the program is not ready to mimic that exactly yet, but it's I think, I'm wondering, there's some other companies out there, and I think I'll be watching a demo on somebody else's product later, so we'll see how it goes.
Amazing. Before we get into them, Suresh, I want to ask Alak a little bit. Where is this the version 1 of this product? Have there been previous attempts at this? Like, what kind of challenges did you face when it comes to building these kinds of things?
Absolutely, yeah. So last year we started with the first direction.
Okay.
So the example that you just saw involves 4 different steps. It's a completely decoupled architecture. So we had to call multiple LLMs and stitch that all together, orchestrate to generate that, the final video, right? So the 2D avatars is what we had it last year. So we wanted to expand that into some of the challenges that Rob talked about. So we went about with the advancements in the multimodal AI, the vision models, Metas 3.2, there's this Claude 3.5 Sonnet. They've been super helpful in the video understanding space. So that's something that allowed us to improve and enhance the version 2 to include the bidirectional translation as well.
Yeah, awesome. I guess, Suresh, can we see some code?
Yes.
Let's go ahead. We're going to go switch to Suresh's screen right now and see some actual code. We'll actually see some AWS console to see how this thing is performing in action, because what I can see right now and you, chat, cannot see yet is some AWS step functions. So Suresh, take us away.
This is showing the narrative avatar use case, which is taking a text or an audio as an input and then creating a ASL video as an output. So it's going to check, if the incoming does not have a text in it. So it's going to go back to starting a transcription job. So it's going to use Amazon Transcribe. Amazon Transcribe will take an audio as an MP3 file and then convert that to a text. Also, it accepts a MP4 video file and then convert to a text. And then once the transcription job is done, it's going to extract that text and then put that in a step function variable. And then once that is done, it's going to send it to a Lambda function, the text to gloss Lambda function. So this Lambda function is going to convert English text to a ASL gloss.
Okay.
ASL gloss is a grammatical or a representation of the signs. And then once we identify the signs, it's going to convert the gloss signs to posts. The post is the one which is going to look at the database set and then see, if the sign is already in the data set, it's going to do it. And then it has a fallback logic and other stuff. I'll go through that code.
Okay, excellent.
And then once that is done, it's going to, let me
zoom out. There you go. Okay, and it goes to the end.
It goes to the end. And then also stitching is happening within this Lambda function.
Okay.
I'll walk through the code of both, looking at the post video, stitching, and then blending.
Okay, I would love to see that, because I'm quite interested to see how the text to gloss works. I assume you're using some generative AI model out there to help you generate those things.
So let's look at the text to gloss first.
Can you slightly zoom in so our chat can see this thing nicely? So, I don't know, Command Plus or I don't know what PyCharm does.
Yes, sir.
It can do, there we go.
Is it better?
Yeah, way better. Thank you so much.
Okay. So this particular Lambda function is using Amazon Bedrock's Converse API.
Okay.
And then calling Anthropic Claude 3.5 Sonnet V1, I think V1.
Yep.
And then it's using the Converse API. And then I'll show you the prompt. It's a simple prompt. The prompt is going to say, these are some of the examples. Like, if you have, see a sentence like you, and then that should be converted to IX2P. And then if you look at here, I did not give anything for 3P, third person.
Yeah.
Like only I gave the example for 1P and 2P. And then the LLM is able to figure out, he, she should be translated to 3P. And also I gave my, even if you say I, it'll translate to 1P. The model has the smartness to do it. And then we are saying translate that English text to ASL glass and return only the glass. Don't provide the explanation, because otherwise it will use more content than I need for this particular use case.
Okay.
So that's the first step of the process, where it's taking text and then converting to the glass.
Okay. And I want to see actually what kind of inference parameters are you using, because this is kind of also one of those key things when you have to be, something needs to be quite precise. So I see your temperature is extremely low, so you want to reduce the randomness here,
exactly.
Right?
Yes. Yeah. That's a good point. Yes. That's I was playing with multiple inference parameters, and then finally set to 0.1 because we don't want that variance. We want the accurate translation from English text to glass.
Excellent. So this takes transcribed video and converts it into gloss.
Yes.
Okay, amazing. Okay,
Now,
what happens next?
Next up, we are going to take the gloss and then create the video.
Okay.
The reason is like we are not creating a real-time avatar video. That takes a lot of time.
Okay.
Because stable diffusion and the human-like avatar takes a long time.
Right.
So that's the reason we are creating a pre-created avatar for each gloss and then storing that in S3.
Okay.
And then storing the S3 key in a DynamoDB database.
Okay. Okay.
So I'll show you the code where we are doing the translation. That will be in gloss to pose.
This is fascinating. Again, and Alak, maybe you can talk about, we are using here, are we using the latest model, the Nova models right now for some of these things?
That's going to be a future.
It's going to be a future thing.
So we, as Suresh was walking through the 4 different steps, which are stitching together. So our end goal is like when the any-to-any model comes out next year, our idea is to simply take any modality, right?
Yeah.
We can avoid all these steps and make the system more accurate and performing better.
Exactly, yeah. Multimodal models, try saying that fast 10 times. But they're the ones that, they're the real heroes here that are solving kind of these problems. So, okay, so gloss to video.
Yeah, so it's getting the glass sentence and then splitting that to each glass and then looking at the DynamoDB table for the glass. And then if it's not found, it's falling back to the finger spelling.
Okay.
So that's what, like, where it's using each alphabet and then doing it. And then like if you look at the demo, I'm creating 3 types of videos output. So I want to make it faster. So I'm using a threading, the Python threading.
Okay.
So you see 3 threads. Here one thread is doing the pose, one thread is doing the sign, and another one is like a human-like avatar.
Okay.
So each one is going to look at different type of video file, and then it's going to combine it. So let's look into the actual code, the process video code. That's the one. It's like downloading that from S3.
Mm-hmm.
So you can see it's downloading from the S3. And then it's going to combine that using FFmpeg.
Okay.
And then create that resultant video, and then uploading that to the S3, and then creating a pre-sent URL. And then the pre-sent URL is sent back to the UI.
Yeah.
And then the UI is going to display the video.
I love that. I love that. I think that's such a fascinating thing, because again, generating video in real time is still very expensive. It's not just very expensive, it's very slow. So being able to have predefined videos and you can just use hard logic here. Remember, friends, if it doesn't have to be Gen AI, it shouldn't be Gen AI. So this is just using hard logic to actually stitch these videos up together on the actual front end, which I do really like. So nice, awesome. Okay.
Yeah. Just one more thing to add.
One more thing, yes.
So when we are stitching the videos together, so for example, hello, like it goes from the forehead, and then you will from here, there'll be a sudden drop in the hand movement. So when we are stitching the video together, so this version we introduce smoothening.
Okay.
So it uses a model called SmoothNet, and then it combines the video and then creates an intermediate frame so that it will have a cohesive video as an output.
Amazing.
That's one thing to show.
Amazing. I love that. Again, just slight improvements of all of these things. Excellent. Is there anywhere people can check this demo out? Is this publicly available?
Yes. Our last year version is in www.aslavatars.com. It's a live demo. You can go and play with it and then do a one-way translation. And then we are planning to update that URL with this new code. And then also we have published this one in AWS samples.
Okay.
And then we are going to update that with the new code.
Amazing. We're going to be dropping the link in the chat for that webpage so you can go check it out and be on the lookout for the new version of the code. We're wrapping up the segment. I'll first of all give a heartfelt thanks to Rob and all the ASL interpreters out there. Thank you so much, Rob. Thank you so much. And Alak and Suresh, thank you so much for working hard on this kind of an application that enables a lot of folks to be able to consume and produce more content. So this is such a valid use of generative AI that I really can't talk about it enough. Thank you so much, my friends. It's great. Chat. do not go anywhere. There's a lot more content coming up here right on the on twitch.tv/AWS OnAir channel. Stick around, more content coming in, and I hope you enjoy this thing, and check out the chat for the links. Folks, see you soon. Bye.
Thank you.
Thank you so much.
Thank you. Thank you.